Okay, hey y'all. We are actually going to do some synthetic division problems. Synthetic division is a method for manually performing Euclidean division of polynomials. What we did previously when we did long division, that is just your normal run-of-the-mill Euclidean division of our polynomials. When we do that though, remember we had our dividend and we had our divisor, and you took the first term of our dividend and you divide it by the first term in the binomial of the divisor, and then you put the quotient up here and then you multiply. I mean, it's a lot, right? And on top of that, there's also your division of exponents, your multiplication of exponents, adding and subtracting of exponents. It's a whole lot of actual computation that's involved. This right here, I even wrote that our advantages to using synthetic division is we're going to have fewer, I can't even say it, fewer calculations. There's less writing than long division, and we're not going to have to worry about any exponent rules. So this, I believe, is going to be an easier method. The only thing you just need to watch out for is if a problem explicitly states to use a specific method, you have to use that specific method. So if one was to say use long division and you did synthetic, even if you get the correct answer, you didn't actually follow the directions. If it says to just divide the polynomials, you can do either. If it says synthetic division, you would do this method. Okay, so let's do our first problem. Say we are told to divide the trinomial 4x squared plus x and a negative 18 by this binomial x minus 2. And on the right-hand side, what I'm going to do is write what it equals. Okay, so this is what you do, y'all. We're going to actually just pull the coefficients from that trinomial. If it is a negative, you need to make sure that you include that sign. Okay, so again, I'm just going to bring down the coefficients of my trinomial. Okay, so what I'm going to do is actually, I have this right here, this box here, and this box here. Okay, so that's going to be how you set up your problems. Okay, so underneath your trinomial, leave yourself some space. And then to the left of the first term, you're going to do almost a complete box. And then to the very far right bottom, you're going to do, I mean, honestly, if you did an actual box, it's fine. What we do for what we're using to divide this polynomial with, the divisor is actually a factor of x minus 2. You set that factor equal to 0. So we get x minus 2 equals 0. But I know that that actually is x equals 2. So our 2 is what we are going to divide by right there. That's what we're going to use in our synthetic division. So very first step, whatever your first term is here, you bring it down, use your arrow. Okay? And then what we do is we take our 4 right here and we multiply it to our 2. The product that we get goes right here. Okay, so if you do 4 times 2, you get 8. Those signs are the same, and so you get a positive 8. Okay, our next step is to take, I wouldn't want to say sum. I guess you could say sum. You have to really pay attention to your signs. If the signs are different, you could technically be adding a negative. If they're both positive, then of course I'm just taking a sum. Even if they're both negative, you could be taking a sum of 2 negative numbers. I'm going to say combine. That way I'm accounting for the fact that they might not be the same numbers. I could be doing addition or subtraction. So what you do is we're actually going to combine these two numbers, and what I get is going to go right here, right under it. So if you look at 1 and 8, those signs are positive. What you do is you add and you keep their sign. so it'd be a positive 9. And then we're going to do that step again that we just did, where I take my number here, multiply it by here, product goes here. So if you do 9 times 2, I get 18. Those signs are the same, so it's positive. And then I'm going to combine these terms here with my answer going inside of that box. So if you look, I have additive inverses. And what that gives me is 0. Getting the answer of 0, this is what we call our remainder. That is what we call our remainder. And a couple more problems, certain things will kind of start getting called other things. We'll just kind of define them more greatly than we are now. Knowing that I did get a 0, that does tell me that 2 is a number that can divide this trinomial right here. And so I know that this division is possible. Even if there is a reminder, if it does tell you to write it, we would write it the same way we did earlier, where you would do your reminder over your divisor. So here, what I notice is I have a 4 and I have a 9. So this is what I do. I'm actually going to take the two numbers that I got to, and I write 4. You're going to look here. That leading term started with x squared. And so what you do is you reduce the variable by 1, your exponent, you reduce that variable's exponent by 1. So it was x squared, now it's just x. And then our 9, that is a positive 9. That term here was just an x variable, which had an exponent of 1. If you reduce it by 1, you get x to the 0, which is just the number 1. So because it was 1 and I'm reducing it by 1, that 9 does not have a variable attached to it. And so that would be your final answer. I thought, there we go. That would be your final answer for that division. Okay, so now let's do this second problem. We're going to set it up the same way. We're going to pull our coefficients, being sure to be mindful of signs. I know that I'm going to draw, it's kind of like an elongated L-shaped, a portion of a rectangle. I've got my square here. I've got my square here. Your square will always go under your last term. If I notice that I've got x plus 3, what you do is you set it equal to 0. So I would actually get an x minus 3, negative 3. That is what goes here. Our first step in the actual process is to bring down whatever your first term is here. And then we're going to multiply these two with a product going here. 6 times 3 is 18. Those signs are different, so it's negative. And then I'm going to combine these with my answer going here. If you look at 5 and 18, those signs are different. So what you do is subtract and keep the sign of the larger. And then I'm going to repeat again, doing the multiplication with these two terms. Again, always make sure you watch your signs. And sorry, but the product goes right here. Oh, negative 13. Okay, so now if I do that multiplication, I get 13 times 3, which is 39. Signs are the same, so it's a positive 39. And then here is where I do my combination with my answer going here. If I look at 39 and 10, those signs are different. So what you do is you subtract, keep the sign of the larger. So our previous example, what we ended up getting for our remainder was just 0. So I just wrote the binomial 4x and a positive 9. For this example, I don't get a 0. So what happens is I'm going to write my answer. I have my 6, lower it by a degree. I have a negative 13, lower that by a degree. And then I'm going to add my remainder over my divisor. Now, you do not write it over negative 3. You write it over the factor that we have up there, which was x plus 3. So that would be your final answer. Okay, I'm going to do another video. Make sure y'all ask questions if you have any. Thanks. Bye.